Okay, Spartan fans, so we are going to look at graphing exponential functions. So if you recall from yesterday, our two graphs, we were talking about the number of folds and the area of each section versus the number of sections, and graphs look something like so. And we talked about how there was an asymptote at y equals 0 for both of these functions. So today we're going to look a little bit more specifically at the parent function. So there's not an exact parent function for an exponential function because the base of the function could be different. So here's what I mean. The parent function is going to be a, so we should recognize that from graphing other parent functions, times, and this time we're going to talk about b, meaning the base of the exponent, to the x minus h plus k, and hopefully h and k look familiar to you. All right, let's talk about a couple of things. First, anything to the 0 power except for 0 is 1. And hk for previous graphs was the vertex. So this graph isn't really going to have a vertex, but we'll talk about that as well. If b is between 0 and 1, this is going to be referred to as decay. And if b is greater than 1, it is going to be referred to as growth. By definition, b cannot be less than 0. Let me try and think about how I'm going to write can't be less than 0. I think I'm just going to write it out. b cannot be negative. How's that? Okay, so when I graph something like y equals 2 to the x or y equals 3 to the x, the problem is the parent points are going to change each time. So let's just start with, f of x equals 2 to the x. You did that with the number of folds and the number of sections. So I'm just going to kind of make a quick little table of values. And you can go ahead and pause the video and do that for yourself. And I always plug in a couple negatives, a couple positives, and 0. And we've already talked about how anything to the 0 power is 1, and 2 to the first is 2, and 2 squared is 4. Negative exponents, 2 to the negative 1 is not negative 2, it is 1/2. 2 to the negative 2 is 1/4, not negative 4. And so if we plot these points, I'm going to draw a really small graph here. If we plot these points, as x goes further and further and further in the negative direction, the value of the fraction gets smaller and smaller and smaller, hence why there is an asymptote. So anything to the 0 power is 1. You get 1, 2, 2, 4, negative 1, 1/2, negative 2, 1/4, and the graph looks something like such. And then draw in your asymptote. Okay, so the domain is going to be all real numbers, and the range is going to be y is greater than 0. Not exactly 0. There's no number that you're going to plug in for x that is going to make y 0. Okay, so 3 to the x is going to be very similar, and 4 to the x is going to be very similar. The difference is how fast the graph is growing. So I'm actually going to just graph it on the same grid here. So if it's y equals 3 to the x, anything to the 0 power is still 1. But now, when x is 1, y is 3. And when x is 2, y is 9. That doesn't really fit on my graph. And it's still approaching 0. The growth rate is just faster. Still goes through 0, 1. Okay. And then on the flip side, decay is going the other direction. So if I did the f of x equals 1/2 to the x, and I made my table of values, it's very similar to 2 to the x, very similar to 2 to the x. And again, you did this yesterday with area. Instead of f of x, let's write 1/2 to the x. Again, I'm going to plug in some negatives and some positives. Anything to the 0 power is 1. 1/2 to the first is 1/2. 1/2 squared is 1/4. But now 1/2 to the negative 2, flip. You get 4. Not negative 4, not negative 1/2. 1/2 to the negative 1 is 2. Flip. Make the exponent positive, and that's just 2. All right, so when I graph this, so here I'm going to show you something pretty cool after I sketch a pretty basic graph here. So -2, 4, -1, 2-ish. Not the greatest of graphs. Let me try to erase this little piece. You know what? I'm going to redraw the graph. It looks kind of crappy. Okay, and same domain and range as growth. Okay, I'm going to tell you something pretty cool. I think it's pretty cool. That's because I'm a geeky math teacher. Here we go. So if you look at y equals 1/2 to the x, 1/2, this is the exact same thing as 2 to the negative 1 to the x. So I took 1/2 and I wrote it as 2 to the negative 1. Well, if you multiply the exponents, you get 2 to the negative x. Okay, so here's what's totally cool. 2 to the x was here. What's this graph? This is 1/2 to the x, but notice 1/2 to the x is the same as 2 to the negative x. So 2 to the x, 2 to the negative x, that's an x-axis reflection. Sorry, y-axis reflection. This is a y-axis reflection of 2 to the positive x, and here's why that happens. So I'm going to write this out for you. 2 to the negative x is a y-axis reflection of 2 to the positive x. Here's what happens. Notice, you know how I always say opposite, like when you guys are doing a quadratic formula or you're finding the vertex of a parabola, and I always say opposite of b over 2a. I never say negative, and here's why. There's a method to my madness. X, negative x, x, those are opposites, right? The negative x is the opposite of positive x. Well, here's what's happening. Positive x values are on the right of the y-axis. Negative x values are on the left of the y-axis. They are opposite. Positive, negative, opposite. And so when you take the opposite of x, when you go from positive values of x to negative values of x, or vice versa, negative values of x to positive values of x, that is naturally a reflection over the y-axis. All right, so we're going to do a couple problems with shifting. All the shifts are the same. If you can shift a parabola, if you can shift a square root function, if you can shift a cubic function, then you can shift a exponential function. So I'm going to say, how about 3 times 2 to the x plus 1 minus 4. Okay, first of all, this is not 6. You cannot multiply a coefficient times a base. No, 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 no. So let's describe the transformations. This is going to be left 1, down 4. Down 4, that's your k. Your h, what number plus x is 0, and that would be -1. And then the 3, this is going to be a vertical stretch, or it is a compression to the y-axis. if it is easier for you, this is one of the few times when I think making a table of values might be helpful. Okay, so the normal domain is all real numbers. That does not change. The domain of this function is all real numbers. Okay, but the range, so the parent range is y is greater than 0. But this has been shifted down 4. So now that I have shifted it down 4, I am shifting my range down 4. So now my range is -4 to infinity, and my asymptote is at y equals -4. Okay, you can do parent points if you want. So the normal graph, regardless of what the base is. In this case, the base is 2. Anything to the 0 power is 1. This is for the parents. 1, 2, 2, 4, -1, 1/2, etc. If it's easier for you and you just want to make a table of values, feel free. I'm going to do parent points. That's pretty much consistently what I have done all year. Okay, so I need to draw a bigger graph down here. All right. And since I'm going down 4. Okay. So if I'm shifting this graph left 1, down 4. Left 1, 1, 2, 3. Here's my new origin point. Okay. That is where my asymptote is going to be. Okay, and then from here, 0, 1. All right, but that's not true. So remember, the a value is 3. So I'm going to multiply all of my parent y values by 3. Okay, so 0, 1 is going to become 0, 3. 1, 2 is going to become 1, 6. 2, 4 is going to become 2, 12, which is not going to fit in my graph. -1, 1/2 is going to become -1, 3/2. -2, I didn't write this one down. -2, 1/4 is going to become -2, 3/4. And so from my shifted origin, so here's my new origin, I'm going to plot the point 0, 3. I'm going to plot the point 1, 6. So here's my origin, 0, 3, 1, 6, 2, 12, which isn't going to fit, etc. Let's see, -1, 3/2, -2, 3/4. And this is a big-ish. And there is the graph. If you prefer to make a table of values, I would highly recommend that you start with -1, because when you plug -1 in for x, you get 0. I'm sorry. Yes. When you plug in -1 for x, you get 0 for the exponent. So let me just show you what that would look like if you did a table of values. I would definitely start with -1. You cannot do a mixture of both. You're either doing a table of values or you're doing parent points. So if you plug in -1, that's 3 times 2 to the 0 minus 4. So that's 3 minus 4, which is -1. And notice my graph goes through -1, -1. So I would plug in -1, and then I would plug in a number more than -1, so I would probably plug in 0, and I would plug in -2, and you'll get the same graph. Your homework is a worksheet. Make sure you pick that up from the sub, and if you would like to, do the book problems on the back. Pick up the homework worksheet from the sub, and then do the book problems on the back.